This one is cumulative, right? This class is cumulative.
Yeah, the final in here starts on page 1.
Dead in the damn water.
Yes, yes. Okay. Now, I know you guys' brains are fried if you've been up in the lab and just did your midterm, okay? But life's a bitch. We are going into the nervous system, the hardest part. These next 3 chapters, well, actually the next 4 chapters are a bear. And I'm going to try and change the way that I'm talking to you guys to help you a little bit, okay? And let me give you a little bit of advice. Start tonight, and everything we do from right now until we finish, review it several times this week. Don't wait till next Monday morning to try to figure out, oh, what the hell did he say last week? Review it over and over and over and over and over and over, because listen, y'all, you will drop 20 points from what you did today.
What?
On this next test. It is a bear. Okay?
Okay.
I kid you not. Study, 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 study. Now, I'm going to give you a 20-point extra credit. Okay? When we get down about 2 chapters from now, I'm going to give you a 20-point extra credit. And that's going to help it some. But you guys turned in a 15-pointer today, and it might pull it up. We'll see. Y'all did not do well. This was not your. What made that so hard? Was it because you were studying for midterm?
Yeah. No.
It was.
Yeah, all them hard words.
It's fixing to really get bad. It's just the discussion question on the back, not the one that you did take home. Okay. So wipe your brains clean, okay? Wipe them clean, because really, 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 I'm not kidding you, the next one's going to be bad. And we're fixing to start off. We got one on fundamentals. We got one on central nervous system and one on peripheral nervous system. Then we're going to have a test. And then we have one chapter on the autonomic nervous system and one chapter on special senses. So your last test will just be on 2 chapters. But half of that is the autonomic nervous system. And it's a really good example of how hard the nervous system is, because it's 50 questions, 2 chapters, and autonomics is on the first 25 questions. Special senses is on the second 25 questions, and all the red marks will be over here, and just very few red marks over there when I'm grading papers. So it's all about the nervous system. It's all about the nervous system, okay? So y'all, I know it's boring, it does not make sense, but try to stay with me. Tonight, next week, the next week, and the next week. Ma'am?
Wait, when is the exam? When is the exam for this?
It's going to be
The 9th,
After spring break.
the 9th, is that when it is?
yes.
April 9th? And remember that, we got a week of spring break in there,
We're going to meet during spring break.
okay? Now, this chapter on fundamentals is stuff about the next 4 chapters, okay? The fundamentals is things that we need to know about all the nervous system in general in order to understand it, okay? And I know it gets really hard, but this first one is long, and it's hard because we have to talk about the fundamental aspects of the nervous system. The nervous system has some functions. It gathers sensory input, and we call that sensory input a stimulus or stimuli. It integrates that input, it processes it, it interprets it. It sends it to the brain and says, hey, this is a stimulus, this is input. And the brain then makes a decision, okay? Decision has to be made. The brain decides if it wants to ignore it, or if it just wants to accept it, or if it wants to do something about it, okay? And to help us get started, whack my hand. Ah, an impulse, a stimulus left here and went up my nerve, up to my spinal cord, up through my thalamus, and then out to my cortex. On the way up, the thalamus tells me if I like it or if I don't like it. And then it sends that connotation out to the cortex, and the cortex decides, do I want to do anything about it? Did it hurt? Did I like it? Maybe my cortex says, the witch hit me, hit her back. Make sense? So we take that stimulus, that input, and we integrate it, we interpret it, and we make a decision if we need to. Maybe I figure I'm the manly man. I'm not going to let her know that I even noticed it and just ignore it. Make sense? Any of those are proper decisions, but I get to make that decision out here in the cortex of my brain. You with me? Okay. So we gather that stimulus, we gather that information, we send it up, we interpret it, we integrate it, we make a decision. If we choose to respond, we send an impulse down an efferent pathway to an effector organ. I said that wrong. An afferent pathway. No, an efferent pathway. And we call that motor output. Okay, just to kind of sort of the way it works. Sensory afferent, motor efferent. Sensory goes up, motor comes back down. With me? Sensory on the way to interpretation, motor comes down to respond to that. With me? Okay. Now, our nervous system is organized. It's organized a couple of different ways. It's organized structurally into the central nervous system that we call the CNS. And the central nervous system is the brain and spinal cord. The CNS is the brain and spinal cord. The CNS is the brain and spinal cord. It's our command center. It's where we integrate. It's where we interpret all of that sensory input. Then we have the peripheral nervous system, the PNS. And the PNS is made up of the nerves that extend out from the brain and spinal cord. We have spinal nerves that go up and down the spinal column, and we have cranial nerves. And those guys do not go down the spinal column, they go straight out from the cranial vault.
And those are part of the PNS?
PNS, cranial nerves are PNS. CNS, brain and spinal cord. PNS, those nerves extended out from the brain and spinal cord. Spinal nerves go out of the spine, cranial nerves go out from the brain. Then we could organize it functionally. And functionally, our PNS has sensory afferent neurons that take sensory input towards the CNS, and we divide those sensory afferents into somatic afferents that comes from the skin and the muscles and the joints, and the visceral afferents that comes from the organs. So our sensory afferent can be either somatic, skin and muscles and joints, or visceral afferents from the organs. Those are sensory afferents. Then the motor afferents take information from the CNS down to the effectors. In the somatic nervous system, the motor output, the effectors, are skeletal muscle. In the autonomic nervous system, the effectors are smooth muscle, cardiac muscle, and glands. In the autonomics, we have two divisions, the sympathetic division division that is our fight and flight, and the parasympathetic division that is our feed and breed. We are not there yet, but since we just said what we said, we're going to put a little rule of thumb. For all practical purposes, the sympathetic division of the autonomics stimulate things. The parasympathetic division inhibits things. Now, there's going to be some big exceptions to that, but for all practical purposes, the sympathetic autonomics stimulate and the parasympathetic autonomics inhibit. Now, did everybody get all those? All right, tell me how our CNS is divided structurally, the CNS.
Brain and spinal cord.
Brain and spinal cord, and we call that the CNS, and then what's the other division?
PNS.
PNS, and it is?
Cranial nerves.
Cranial nerves and spinal nerves. Functionally, sensory afferent, bringing sensation towards this brain, towards the brain, and motor efferent, taking information from the brain down to an effector. If it is a somatic nerve, the effector is skeletal muscle. If it is an autonomic nerve, the effector is smooth muscle, cardiac muscle, and glands. Autonomics divided into sympathetics and parasympathetics. The sympathetics excite things, the parasympathetics inhibit things. So that brings us, that's how we organize it, and so that brings us back to our starting point, the cells of the nervous system. So we're going to talk about the different cells in both of the CNS and the PNS. In the CNS, we have some supporting cells. These guys are non-excitatory, and we call them neuroglia, supporting cells. In the CNS, those supporting cells are astrocytes, microglia, ependymal cells, and oligodendrocytes. So in the CNS, our supporting cells, astrocytes, and astrocytes are anchors, but they give us the blood-brain barrier. Astrocytes give us the BBB.